Oh, it's actually 87.79. How many digits should we use here? Well, you should use them all. If you're using a calculator, you know, why bother truncating your number, right? So just use them all. So 3851717. Sure. Okay. But we want the fifth. How do we get the fifth root on a calculator? And you should have a scientific calculator. I'm looking around, seeing most people do, and you should know how to use it to do something like this, right? So what do you do here? Well, the fifth root is the 1/5 power, right? So I'm going to say here comes an exponent. What exponent? 1/5, which you can also write 0.2, or you can put it in parentheses, 1 divided by 5. But that's 0.9743 then. So this is approximately 0.9743. So that completes my model, right? F of t is going to be 221.2 times. So what is R? When we're talking about the annual rate, it's going to be about 2.57% negative, right? Because it's going down. So when I think of the base as 1 plus R, I'm going to write R as negative 0.0257, right? Okay, so what is their question? We got all our model and everything, but I've forgotten what they wanted. Enter in the function. Okay, so 221.2 times, I guess in parentheses, 0.09743. Raised to the power of t, because that's the independent variable here. Did I do that correctly? Yeah, pretty tight, looks right. So, assuming the model remains accurate, estimate the death rate in 2034. Well, that's going to be 35 here, right? And that's a big assumption, by the way, that the model remains accurate. In fact, that's sort of, what do you call that? It's a rhetorical device. So if you say that it remains accurate, that means that it was ever accurate in the first place, which just because it fits these two data points doesn't mean it's accurate. So we're also assuming that there is an exponential model that fits this pretty well in some range. That range probably does not include 35 years later, right? I mean, that's just ridiculous. So, you know, I caution you in using these models to use them responsibly. This is not an example of that. But in theory, you know, you could, I suppose, especially if you're trying to, you know, make some argument that suits your purpose. So what is that? Well, so 35. Okay, so we're going to go back to here and say, all right, raise this to the power. So this is our growth factor, right? So we're going to have 35 factors of points. So how do we get that? Well, we raise that to the 35th power. Oh, yeah, right? And that's going to be then about 40% of our starting value, which is 221.2. And we get about 89 people. Can we just copy that?
I don't think you selected it. You just selected it.
I guess we have to highlight it first, huh? Now we can copy it. Go back over here, paste it in. Round to the nearest tenth, they say. Well, what if we don't? It doesn't matter.
Seriously, like,
If
if we don't round, it doesn't accept it.
Oh, really? Well, I know that happens. It's kind of a weird thing. I'm always curious to see, is this one of those, and what's the difference between the ones where you? Yeah, this is the teacher's one. Yeah. No, I have the same exact algorithm that you get.
Do you though?
Yeah. Okay, so those are both good, all right, so that's moving on. If this is too similar, we'll just move on, whatever. The current student population of Portland is 2,800. Portland, Maine, or Portland, Oregon. There's probably a Portland, Florida, right? So they don't say which Portland, so. If the population decreases at a rate 7.9% each year, again, oftentimes math people are challenged in the English language. So that is a sentence fragment. If the population decreases at a rate of 7.9% per year, period. It's not a proper sentence. So if they put a comma there, that would be okay, right? The comma, what will the student population be in 9 years? Okay, so what's the model?
We're gonna use the same scratch space here, huh?
Decreases, right? So R is negative 0.079. So if I have the population in year T is the original population times 1 plus R to the T, this is an annual thing, right? So the initial population is 2,800. T is the years since now, right? Oh, and it's X, not T. Okay, fine. R is negative 0.02079. And so that comes out to 2,800 times 0.921 to the X power, right? And they want to know in 9 years. So P of 9 will be this number. And to evaluate this, we need to do what first? The exponent, right? Follow the order of operations. So I'm going to say, okay, I've got the exponent, apply the base, what is it? 0.921, and I've got an exponent of 9, and I'm going to multiply that by 2,800. So you can see I'm going to have about 48% of the starting value, which is 1,335. I'm just going to copy this so I can get it highlighted. Oh, the whole thing